Welcome to the Mastering React series. In this first video, we're going to take a look at getting started with React. My name is Eric Green. This video is brought to you by Wintellect Now. So we're going to take a look at an overview of React, understand what problem it solves, and what makes React a little bit different from other UI libraries out there. Then we're going to take a look at the development environment that we're going to be using for developing our React applications. We'll take a look at a tool called Create React App. Next, we're going to take a look at what a component is, understand how they work, and then we're going to take a look at creating functional components. Then we're going to take a look at using a better syntax to create our functional components. We're going to learn about something very useful called JSX. Then we're going to take a look at working with multiple files and how to import a component from a file. Then we'll take a look at using data and expressions with our JSX. And we'll take a look at how to embed those inside of our components. And then finally, we'll take a look at how to pass data into our components using something called props. To get started with React, we first have to understand what problem it solves. What exactly is it used for? React is a user interface library. It is used to help build user interfaces that allow people to interact with your application. Now, React itself is actually created by Facebook, and it's known for three basic things. Number one, it's declarative. Number two, it's component-based. And number three, learn once, write anywhere. While we're going to walk through lots of React stuff here, if you want to visit the website, reactjs.org, you can actually go read the official documentation as well as other news and things like that that surround the React project. The first thing we're going to take a look at is the declarative aspects of React. By declarative, we mean that we can use React without having to trouble ourselves with the underlying implementation details of how to do things like updates to the UI. In the traditional web UI development model in the past, people would use libraries such as jQuery to be able to update the web browser's DOM structure so you could see changes that occurred to the UI as a result of user interaction and changes to data. However, writing this UI update code usually was very inefficient. Not just inefficient in terms of time to write it, but just inefficient in the way that the average developer would interact with the actual DOM structure. With React, you don't have to trouble yourself with those details anymore. You simply tell React what you want, you give it the data that it needs, and then React takes care of actually updating that underlying DOM object structure and does so in the most efficient manner, thereby improving the performance and speed of your application, but also improving your development time because you're not having to spend all the time doing the low-level operations. It's also declarative in that the syntax we're going to be using is called JSX for actually creating the components. JSX is similar to HTML. It is not HTML, but it is similar to HTML. And the nature of HTML is it's a markup language and it's also declarative. And so using JSX is also going to give us that declarative feel to creating our components. React is component-based. So what exactly does that mean? A component is basically an encapsulated user interface element that combines a template with data. Now, in React, we don't really speak in terms of templates. I use the term template because a lot of folks that come to React from other user interface libraries and frameworks are used to working with string-based templating and then applying data to those templates. Well, in React, we don't have string-based templates. Everything is a function call. Nevertheless, that presentation logic, you might think of it as a template, that presentation logic is combined with data inside of this encapsulated user interface thing, this element. And we call it a component. And we can create lots of components and we can actually put them together to build larger components. Components can receive data from the outside, we call that props. They also have the ability to manage their own state, although as a general rule we try to stay away from that. But components make all the difference when building your UI applications. Instead of building big monolithic templates that paint the whole screen, now we build lots of smaller pieces that we compose together to build more complex UIs. Another cool feature is the concept of learn once, write anywhere. Now, when we know the promises that things like languages have provided over the years, like Java, where you can basically write your code once and run it anywhere, and those promises don't always prove to be as true or helpful as we would like. Nevertheless, React should not be thought of as a user interface library limited to a web browser. You can actually use React to build user interfaces not just for web browsers, but also for native mobile applications. The idea with React is that React is not limited to a web environment. You could actually use it to potentially build all of your user interfaces, no matter what platform you happen to be developing on. To that end, the actual core React library is distributed separately from the individual platform-specific libraries for taking your React code and rendering it in those environments. So for example, when you build a web application, you're going to need the core React library plus React DOM. Or to build a mobile application, a native mobile app, you're going to need the core React library and React Native. Now, to get started with React, we're going to need a development environment. We're going to need to be able to set up a project that we can use to edit our React code and be able to run it. Now, the thing about it is that modern JavaScript applications actually have rather complicated project structures. Gone are the days of simply put a script tag at the top of your HTML file, write a little bit of JavaScript code, and you're ready to go. These actual project structures could almost themselves be a full-time job to manage all of the various dependencies, things like Webpack and Babel, and then keeping all of that stuff up to date and well integrated together can be quite challenging. Now, setting up complicated projects is outside of the scope of this course. We are focused exclusively on using React itself, not on how to set up Webpack. So to help us avoid the pain of custom project configurations, what we're going to do is we're going to use a tool called Create React App. Because of the complication of these projects, a lot of UI frameworks and libraries that exist out there in the marketplace today provide tooling to easily get up and running, and that's exactly what Create React App is. Now, in order to use Create React App, we have to have Node.js. While we're not specifically doing Node.js development, in the JavaScript world, all of your development tooling runs as basically part of Node. So while you're not doing Node development, you're going to need Node. So I recommend you head over to nodejs.org and download the latest version if you don't already have it. Be careful, you might have an older version on your computer. You know, if you're running version 6 or version 7, Create React App may not work for you. Definitely wouldn't do anything less than version 8, but I'm currently running version 10 of Node on my computer here. But you could do version 10, version 9, version 8 should be just fine. To create our project, we're going to use a command called npx. Now, npx is relatively new to the Node.js family. Typically, you had Node and npm, but in the fall of 2017, npx was added. And basically, it's going to allow us to download Create React App as well as produce our new application through a single command. So simply open up a terminal window and then change to whatever folder you like to store your projects in, and then run the following command: npx space create-react-app space and then some name for your application. I just called it some app here. You can call it whatever you would like. Your project name must be all lowercase. So don't try to do any type of title case or something like that. It's got to be lowercase. And so because of that, I like to use a dash to divide the words in my project names. Once you've created your project, you now need to be able to start it. To start it, you simply change into your project folder and run the npm start command. You should see the compiled successfully message as well as a URL to your running website. And one nice thing about Create React App is it'll actually open up the website in your default browser. Now, once you have your project up and running, now you need to be able to edit the files. I recommend getting an editor that has JSX support. We haven't talked about JSX yet, but JSX is kind of an HTML-like syntax that's coded directly in your JavaScript file. So an editor would have to have knowledge of what that syntax is, otherwise you're going to get lots of little error messages all over the place. Commonly used editors include editors such as Visual Studio Code, JetBrains WebStorm, Atom. All of these either support JSX natively or through the use of extensions. Whichever editor you do choose, we recommend that it's got 3 different qualities to it. 1, you can actually edit files. Number 2, it has a file system tree view built right into it. The reason for this is that you're going to be editing lots of files in a React application. And while you might be awesome at command line stuff and being able to search through files just by typing text into some type of search window, it is actually much easier if you can just click between files in some type of file system tree view. Another thing you'll need is a built-in terminal. Yeah, you can run a terminal outside of the editor if you want, but the problem is because of all the transpiling with Webpack and Babel that we're going to be doing, and those error messages showing up in the terminal window, it's much nicer if you can see that terminal window right next to your actual code that you're editing, as well as your file system tree view. The recommended editor for this series is actually going to be Visual Studio Code. It's actually an open source editor. This is not the regular Visual Studio, but this is Visual Studio Code. It's an Electron-based open source editor that's totally cross-platform. So when we start doing our code, you'll see that I'm on Linux and I'm using Visual Studio Code. So it runs on Windows, Mac, and Linux. It's an excellent editor. It is by far the most popular editor of all the editors for all the places that I teach at in terms of teaching React and other JavaScript technologies. When we go to code our new projects, we're going to be mostly editing the files in the public and source folders of the actual project that we just created. Let's do a demonstration now of creating a project with Create React App. So let's get started taking a look at a demonstration here of how to create a new project with Create React App. As mentioned before, you will need Node.js to be installed. You can get there by going to nodejs.org. You can see here you can download either the long-term support version or the 10.3 current version. These version numbers change all of the time. So when you go to actually do this on your own, you'll probably see different version numbers. Unless you're intentionally building a program that's going to, need to hang around forever and you want to use the long-term support to ensure that your program will be compatible with the version of Node that you've selected, and you want that version of Node to get regular updates, then go with the LTS. Otherwise, just go with the current. Whenever I start new projects, I typically will go with the current version, and then especially if it's an even numbered version, it'll actually become the long-term support version, and that's the one that I'll use for the long term. In addition to that, you'll need an editor. The editor that I recommend is Visual Studio Code. So this is code.visualstudio.com, and you can come here and download it, and you can see I'm on a Linux machine, so it's offering me various Linux packages for installing it, but if you were on Windows or Mac, you would be offered the Windows installer or the Mac installer. So if you have a few moments, go ahead and download both Node.js and Visual Studio Code. If you don't have Node or you don't have a suitable editor, install those and then come back to here and we will continue with our little demonstration. Okay, so now that you've got Node installed and you've got Visual Studio Code, let's go ahead and switch over to our terminal window, and we're going to go ahead and set up our first little project. So we're going to say npx. Actually, before we even do that, let's actually check to make sure we have Node and stuff installed. You could do node-v, and it'll bring up I'm using version 9.11. If I want to use version 10, I'm using a program called NVM on my Linux box. It's also available for Mac, and I can actually switch Node versions. So now I'm using Node version 10.3 and NPM version 6.1. In fact, if I say npm-v, it'll say 6.1.0. With Node installed, let's go ahead and do our npx install for doing Create React App. So we'll say npx create React App, and then the name of the application that we want to create. In this case, we're just simply going to call it demo app. So demo-app. We'll hit enter here, And it's literally going to go out and first download Create React App. If you've previously downloaded it, it will actually go out and download the latest version. Then it's going to actually create the React application. So you can see here on our folder path, there's our demo app, and it's downloading everything that you need. This can take a couple of minutes, especially if you're on a slow internet connection. Perfect. So now let's go ahead and open up Visual Studio Code. On my system, I can type code dot, and that'll open up code for this given folder. In fact, actually, before I do that, let's actually change to demo app and then do code. If you're on Mac or Windows, you can just launch code using the appropriate means on those two platforms. So we'll go ahead and say code dot, hit enter. Visual Studio Code is now going to open, and you can see over here I have my project files and stuff. In fact, one nice thing about Visual Studio Code is we can actually zoom in. And when we zoom in, it not only zooms in the editor window and things like that, but it actually zooms in the folder tree. This is actually one of the reasons why I like using Visual Studio Code, especially for teaching purposes. A lot of the other editors will let you zoom in on the editor window, but they don't let you zoom in on the folder tree. Whereas this allows you to zoom in on the folder tree, so when I want to point out things to my students in my classes, they can actually see what I'm talking about, as opposed to having really small text in the folder tree itself. Here's the source folder where most of our editing will be done. There's also a public folder if you want to put in like HTML files, images, stuff like that. If we'd like, we can open up a terminal window. It'll tell you down here that you can toggle the terminal window by doing Control backtick. Backtick is the quote character next to the number 1 on the keyboard. You can also go under here and say View and click on Integrated Terminal. That'll also open up the terminal window. There we go. So then we could say npm start. Now I'll warn you, when you go to do this, it's actually going to open it up in your default browser. On my system, Firefox is my default, but I use Chrome for all of my development. So what's going to happen is it's going to open this up in Firefox. I'm going to close that and then reopen the website in Chrome. But whatever your default web browser is, that's what's going to launch when you go to start this. So I'll hit enter here. Perfect. Now you didn't see it because it's on my other screen, but I'm going to copy that URL localhost, come back over to Chrome, and I'm going to paste that right here. And now you can see there's our React application. Now, one cool thing about working with modern JavaScript web development is some of the features that deal with live reloading. And so what's going to happen here is if I were to actually open up the app, or actually open up the source folder here, and go to the app.js file, you'll see here's an example of a component, and it says welcome to React. Well, I'm going to put a bunch of exclamation points at the end of this, just like that. So if you go back over to Chrome, you'll see, boom, and there are the exclamation points. Now, why did this automatically reload? It automatically reloaded for two reasons. One, I have my Visual Studio Code set up to do autosaving. So the moment I typed into these fields and there was a slight delay, it actually saved my file. If you go up under File, you can check Autosave if you want to turn on Autosave. Once the file was saved to the system, it actually reprocessed it because of our little running program down here. It reprocessed it and told the browser to refresh itself. The way the Webpack development server works is that there's actually a WebSocket connection between the server application and your web browser. And every time the server application finds new files and retranspiles them, it then notifies the browser over the WebSocket to reload itself. And that's how the automatic reloading occurs. So what exactly is a component? Components and the concept of components are not unique to React. People have been doing component-based development for decades. So when we talk about components, while that's an important part of what React is, don't think that React created the idea of a component, because it did not. In fact, many of the popular JavaScript libraries and frameworks in use today and in use for many, many years actually use components as well. For example, if you were to check out Angular or even the older Angular JS, Vue.js, Ember.js, all of these utilize components. Now, components have three qualities. One, their presentation logic and data are combined into an encapsulated unit. So we basically have data and we have our logic put together in this unit. You can pass data into the unit. When the component is invoked, arguments can be passed into the unit and immutably used by the unit's logic. And then finally, each component can maintain its own localized state. Now, React fundamentally provides two kinds of components: function-based components and class-based components. In this particular section, we're focusing in on function-based components, but the class-based components will be explored later. Function-based components are preferred, but when component state or lifecycle functions are needed, then you have to go with class-based components. Now, React components implement their presentation logic using JavaScript function calls, as well as JavaScript control flow and looping structures. A lot of UI libraries and frameworks out there utilize string-based template systems, but React does not. It uses all JavaScript functions. So coding all of your presentation logic using JavaScript functions can be quite difficult. Therefore, we're going to use a language called JSX, which is similar to HTML, to actually code much of our presentation logic. Now, the data that's passed into our components from the outside is considered to be immutable within the component, and it's referred to as props. Class-based components can have state, but for reasons we'll talk about later, we generally try to avoid state inside of our components, unless we're doing basically form development. So take a look here at an example of a React component using function syntax. You can see we're using an arrow function here. We have a variable called hello world, and we're simply assigning to it an arrow function, and that arrow function is going to make some calls to react.createElement to basically produce a structure for us where we have a div tag, and the child of that's going to be the header, and the child of the header is going to be the h1. But you can see how it's all JavaScript logic. It's all JavaScript code to actually produce the HTML DOM structure that you see at the bottom. Now, for those of you who are relatively new to JavaScript, or maybe you worked with JavaScript a long time ago, you might not be familiar with arrow functions. So a lot of times when folks get into React coding, they actually say learning the JavaScript was harder than learning React itself. Well, take a quick look here. We have an arrow function that's just a single one-line expression. Then we have another arrow function that's an actual statement block. You'll see where we have the one-line expression, we don't need curly braces or a return statement. We can just say hello world and then have our function called to react.createElement. Well, when we include the curly braces to produce a statement block, we now have to have a return statement. So keep that in mind when you're creating your functional components, to make sure you include the return statement when you actually do define a statement block for the arrow function. Another common mistake that people make is when they do have a statement block and they have a return statement, they think that they can put their next line of code or the thing they want to return on the line after the return statement. But you cannot do that. In this case of hello world, the return statement is actually going to return back undefined when the function is called. It's not going to evaluate react.createElement. In order for react.createElement to be invoked, it would need to start on the same line where the return statement is. So keep that in mind. Don't put new lines after return statements. Always begin the piece of code that you want to return right after the statement on the same line. Now, what are some of the acceptable return types from these component functions? Obviously, we can return back a React element. So saying react.createElement and then returning back our element, that's kind of the default standard that everybody does. They just return back elements. However, you can also return back strings and numbers. So one of the enhancements that was added to React back in the fall of 2017 was the ability to actually return back some primitive values. And in this case, returning back strings and numbers. And so you can just simply return back hello world or simply return back a number. It doesn't have to be a full-blown element. Now, to use a component, we're going to have to reference it inside of a create element call. So you can see here we have create element and then h1 and create element header. h1 and header are both HTML tags. Because they're tags, we just simply place a string that has the tag name, and that's the first argument in our create element call. Now if you take a look, we also have another one called react.createElement hello world. In that case, you won't see a string at all. In fact, we're just referencing the variable that references the functional component. So when you go to create elements, you can either create actual HTML elements, or you can reference a component function and then later on a component class. Now to actually render our component out to the web browser, we need to use the React DOM.render function. So in this particular course, we're totally focused in on the web browser side. While React does work on mobile environments natively, we're focused in on the web browser side here. So the library that we're going to be using for actually rendering out to our specified platform is the React DOM library. Now the React DOM render function is going to accept two arguments. First will be the element that we want to render, and the second will be a reference to the DOM object in which we want to render our component. So in this particular case, we're going to render out the hello world component as the content of the item that has root as its ID. To find the element with an ID of root, we're going to use the query selector function provided by the browser's CSS selector engine. Let's do a demonstration now of creating functional components. So let's go ahead and see about creating our very first functional components and exploring some of the syntax surrounding that. First, I'm going to close app.js, and I'm actually going to open up index.js over here. And let's actually delete the contents of index.js. So index.js is now completely gone. And what we're going to do is we're going to just explore some of the syntax aspects of this, as well as actually produce our own little component and be able to display it on the screen. So at the top, we need to go ahead and import React first. So we'll say import star as React from React. So React is our core library for providing us all these capabilities to build these components. Then we're going to need to pull in React DOM. That's going to be giving us the ability to render these components in a DOM environment. So there's React DOM. Now the first type of component that we're going to be creating in this particular video is something called the functional component. So to do that, we're going to need to define a function. In modern JavaScript, unless we are intentionally using a function that's going to be utilized in some type of prototype inheritance scheme, unless we're intentionally doing that, we always want to go with arrow functions. So if you're not familiar with prototype inheritance, you don't have to know anything about it for this particular course. But if you're not doing prototype inheritance, then you want to use arrow functions. So in this case, we're going to say const, and then we're going to do hello world. There we go. The first thing you want to do is specify any parameters. In this particular case, we're not going to be utilizing any parameters, so we'll just put an open and close parens. And then we're going to put curly braces for our actual statement body. We can also do these as one-line expressions, which we'll talk about also in this course, but for right now, we'll go ahead and have a statement body. Now, inside of here, we can put the actual contents of our component. We're going to say return react.createElement. Because we're going to use an actual built-in HTML tag, we're just going to simply do a string and say h1. We're not going to be passing any attributes to it, so we'll just specify null. And then the content for this is going to be hello world. So there's our very first functional component. So let's go ahead now and render this out to the screen. We'll say react dom.render. And then we're going to list our hello world. So we'll say react.createElement. Now this time, because we're actually using an actual component, there's no string-based name to use. We just reference the actual functional component itself, which in this case is going to be hello world. We don't have any attributes to pass in, and we also don't have any content, so we'll just leave the one argument. So now we need to specify which element we're going to be rendering this into. So we can say document.querySelector. And query selector is going to give us access to the underlying CSS selector engine of the web browser. Sometimes you'll see folks use things like document.getElementById, things like that. You can use those functions, and that's great. But for me, I like to simplify the number of APIs I'm having to work with. So I always use Query Selector. Go out and learn the CSS selectors, then use Query Selector, and then you can make all of your selections from the DOM using one function as opposed to memorizing get element by ID, get by class name, get by tag name, so on and so forth. So we'll come into here and we're going to specify our selector. Now the question is, what are we going to be selecting? How do we find that out? Well, we're going to go over to our public folder and we're going to see there's an index.html file. This is the actual index.html that's loaded up when the web page is loaded. And inside of it, they have provided us a div tag with an ID of root. This is where we're going to be actually rendering our component out to. So we'll do an ID selector, which is going to be a hashtag root. Excellent. So now we can actually render this thing out. You'll notice it's auto-saving and auto-rebuilding. I have not actually had to hit save once yet. So it's a really, really nice setup in terms of making things really fast for us. So let's head over to Chrome here, and boom, you can see there's our hello world. And if we right-click on this and say inspect, we can actually come in and take a look here at the DOM structure that was produced. So you can see here, inside that div tag, ID root, is now the h1 tag hello world. You'll notice there's no extra stuff. There's nothing extraneous being added here. There's no special debug symbols or anything like that showing up. It literally just renders out the h1 tag with our desired content. So coming back over to here now, one of the mistakes that a lot of folks make when they first start working with React is that they're not only new to React, they're also new to JavaScript. And so they'll come in and they'll think, oh, okay, this is kind of a long line. Maybe I'll just put this on the next line. And they'll think that by doing this, this is actually going to work. But if you come back over to the web browser, you'll see that it doesn't work because nothing was returned. All right. If you have a return statement, but you don't put the thing that you want to return right after it, then it doesn't return anything. It actually returns undefined. In JavaScript, you must always put the thing that you want to return immediately after the return statement. Now, in addition to that, we could also make this a one-line expression because we technically only have one expression being evaluated here. Even if you put the expression on multiple lines, it's still only one expression being evaluated. Because it's only one expression, we can actually simply get rid of the curly braces and get rid of the return statement. And for this, you can actually start this up on the previous line in front of the arrow, or with arrow functions, you can actually start the actual expression on the next line. And with this single line, you'll notice there's no curly braces, no return, yet when you go to look at it in the web browser, it shows up just fine. So one nice thing about arrow functions is the ability to eliminate some syntax by being able to do a single expression and make that the return value of the function itself. Now, in addition to being able to render out a single element, we can actually render out a tree of elements. For example, we could take this h1 and wrap it in a header tag. So I could say react.create element header, comma null. But the content of this is actually going to be this h1 element. And then we'll come here and we'll close this off there. So you'll notice, even though I'm going to create two elements because they're all part of the same overall one-line expression, even though it's not really one line, because they're all part of the same expression, I can simply just nest it like this, and it'll return back my header tag and my h1 with my hello world content inside of it. So we'll save that, head back over to here, reload, same result as before. Let's go ahead and inspect that. You'll see there's our header and there's our h1. Now, one thing you want to keep in mind when doing UI development like this is that what you see on the screen may not necessarily be correct. In this case, what we see on the screen is correct, but let's say that we were expecting a header tag to be here and there wasn't one for whatever reason. Our hello world would still look the same. So a big part of doing UI development is ensuring that the actual DOM structure that you're expecting to see rendered is in fact what's rendered, and you can't always judge that by what you see in the web browser. So as a best practice, you always want to regularly check your actual DOM structure being created to make sure it's being created correctly. Another best practice is to always keep your console open. If you have errors or warnings, they'll show up here, and it's possible that the UI renders correctly, but you have errors and warnings and not be aware of it. And those errors and warnings can come back to cause problems later on. So it's always recommended that you take care of those immediately. So there you go. So there's our rendering of our first Hello World functional component. As you saw in the last section, it was relatively simple to create a component itself. But let's be honest. All of those React.createElement calls will become a real pain in the butt. Especially the more presentation logic you have, the more complex it becomes to be able to read all of those createElement calls. Another problem is that most UI developers, especially web developers, they think of the actual UI in terms of HTML elements. There's something about learning HTML usually as the first language that a person encounters in web development, combined with just the syntax of it, that makes it very easy to visualize a web page from the perspective of HTML syntax. So one of the challenges with React is because JavaScript functions are used to build the UI, it's kind of hard to visualize what that would actually look like when actually generating the UI. So a special language called JSX has been created. JSX is nothing more than an alternative way of making function calls. But JSX looks and feels like HTML. But it's very, very, very important to understand that JSX is not HTML. It is not a string of HTML, and we'll talk about that throughout this section. Now, JSX is not valid JavaScript. In order for it to work, we're going to have to use something called a transpiler. A transpiler is basically the process of compiling from one high-level language to another high-level language. In this case, we're going to be transpiling from JSX to JavaScript. The advantage to a transpiler is that it allows us to use, for example, in the case of JavaScript, we can use all the latest language features, then transpile that latest JavaScript syntax into older JavaScript syntax that will work in older browsers. Now, since we're going to be using a transpiler to use the latest JavaScript anyways, incorporating JSX into this is really simple to do. It doesn't require any additional work on our part because we're already using a transpiler. Now, like anything else in the JavaScript world, there's about 100 ways to do everything. So in the case of JSX, there's actually a number of different transpilers you can use. The two most popular are Babel and TypeScript. Now, we're not using TypeScript in this particular course, but if you wanted to do strong typing with your JavaScript development, you could do strong typing with JavaScript and even use TypeScript with React. So it's another option. But Create React App, which is a tool that we're using to build our React application, doesn't use TypeScript. Instead, it uses Babel. So we're going to be using the Babel transpiler. Now, the nice thing, all of this has already been configured for us. We don't actually have to go in and set any of this up. But we'll be able to do all of our coding with JSX. Now, keep in mind, JSX is not a string of HTML markup. I'm going to say this over and over and over again. JSX is not a string of HTML. It is an alternative function call syntax, which looks like HTML. It gives you all the benefits of the visual appearance of thinking about the web page visually in your head using HTML, but all of the power of JavaScript for actually building the UI. Now, transpilation, the process of converting that JSX to JavaScript, actually occurs at development time. It does not occur at production time. So we're going to be doing our editing of our files and saving them, and then the content will be transpiled as we go along. So take a look here at our two little code samples. On the left is our original hello world with all of our little create elements. And then on the right is our updated hello world using JSX. As you can see, the second one is way easier to read. And you can imagine when you start having complex nested structures, The second one is a lot easier to read. It's also a lot easier to code. But you have to remember, it's not a string of HTML. Those actual elements all get converted back to React.createElement in the transpiled code. Now, a very common mistake in JSX code is to write what you see here. People will forget that JSX is not a string of HTML, that it's function calls, and so they'll think that they could take two span tags, or really any two sibling tags, and simply have them both be the return value. But that is not the case. If you take a look at what the code is transpiled to, basically two React create element calls, it becomes obvious you cannot put them next to each other as the return value. So you have to remember, JSX is not a string of HTML markup. It's actually function calls. Each component function must return a single top-level element or a single value such as a string or number. You cannot return two sibling elements. Now sometimes we don't really want a single top-level element, right? We know we have to return one, but a lot of times we don't want one. We really do want to just return some siblings. In that case, we can use something called React.fragment. React.fragment will allow us to basically take two sibling elements, wrap them in an element called React.fragment, but when it actually gets rendered to the screen, React.fragment is not directly rendered. Instead, only the sibling elements themselves are actually rendered. And so this is one way of getting around that limitation of having to return back a single top-level element. Now ultimately, JSX is converted to JavaScript, which ordinarily isn't a problem. But there is an issue that arises when we have HTML attribute names that correspond to JavaScript keywords. The two big ones here are class and for. So on any element, you can have a class assigned to it for CSS purposes. Well, the problem is class is a reserved word in JavaScript. So JSX uses class name as the name of the attribute so that we don't have a collision with the actual class keyword in JavaScript. And then finally we have the for. So on a label element, you have a for attribute which connects the label element to an input control. Well, for is a keyword in JavaScript for a for loop. So we use the attribute name HTML for to avoid the confusion. Now, while JSX looks like HTML, it is actually not HTML5 compliant. HTML5 does not require self-closing tags on non-container elements, like an input tag or a BR tag. However, JSX does require self-closing tags. Syntax-wise, JSX is actually closer to XML, which does require self-closing tags, than it is to HTML. Remember, the HTML part is just look and feel. Ultimately, JSX is a function call. Let's do a demonstration now of exploring JSX. So now let's take a look at a new syntax called JSX. As you could imagine, writing all of these React.createElement calls will be a real pain in the butt. Developers don't typically think of UI structures in terms of JavaScript code. They typically think of it in terms of HTML syntax. And HTML syntax is easier and simpler to write than a bunch of create elements, especially when having, nested tags. So a language called JSX was created that allows us to use HTML-like syntax that really follows more XML-based naming rules, but is really JavaScript function calls inside of our JavaScript code to make it easier to build these UIs. So what we're going to do is I'm going to simply take Hello World, I'm going to make a copy of it, and I'll go ahead and outdent that part. And we're going to comment out the original one just so we can keep it around for comparison purposes. And let's come down here and actually change this to use JSX. And this is really, really easy to do. We're going to simply just get rid of that, change this to header, literally change that to an H1. Close that off. And then have our header. And we're done. That's it. It's a lot easier to read. It's a lot less to type, and it does exactly the same thing. It literally gets transpiled to the code that you see here. So the advantage to JSX is it's easier to work with, easier to understand, easier to visualize. Now, I'll be honest with you, when I first started learning React years ago, I was actually opposed to JSX. At the time, I was big into AngularJS. And in AngularJS, one of the complaints that I would hear from people is, why am I putting all of this logic called directives into my HTML templates? Why am I putting all of this so-called JavaScript stuff into my template? And the point they were trying to make was, why do I have to basically take one language and start shoving it into the middle of another language? Well, when I came to React, I had the same concern, but the opposite. Why am I taking HTML and putting it into my JavaScript code? And that's because I thought of this as a string of HTML, like a string template. But that's actually not what it is. It really is actually React.createElement function calls. It's just the syntax is slightly different so that it makes it a little easier for us to work with. But there is no string-based templating here. These are literally function calls. So we'll come down here. Let's go ahead and change hello world to use our syntax. You'll see we have a self-closing tag here. In JSX, if you have non-container tags, such as referencing hello world or maybe an input tag or a BR, it has to be self-closing, which is an XML thing, not an HTML thing. In HTML5, the requirement for self-closing tags went away for non-container elements. So you can kind of see JSX is like a mix of HTML, a mix of XML, and really an actual JavaScript function call. So if we save that and come back over to our web page here, and let's load up the actual web page, you'll see there's our hello world once again. Everything looks fine. Well, one of the things I like to do sometimes is actually come in and throw a couple extra exclamation points just to verify that everything got processed correctly and I'm not seeing the previous page loaded up from the cache or something like that. If I come back over here, you'll see there's my extra exclamation points. Now, when working with JSX, a very common mistake that I will see people make is to do something along these lines. They'll actually come in here and say, in addition to having header, what if I wanted to have, maybe a footer? And they'll come into here and they'll put a footer like this, and then maybe they'll put some content, copyright 2018, a cool company. And close off our small. And they'll do something along these lines. They'll think, oh, I'm just returning HTML, and they'll think this is perfectly valid. The problem is it's not perfectly valid. Why? Because these are being converted to function calls. And you can't sit there and have return back like just two function calls right next to each other. It doesn't work like that. So you'll notice down here we actually have an error being displayed. Adjacent JSX elements must be wrapped in an enclosing tag. So one way to solve this problem, we could come in and we could say div. Always make sure you keep your code properly indented. A lot of tooling will do that for you, but I, as a matter of habit, just always indent my code as I'm typing it out. Now you'll see everything looks good. Head back over here. There's our header and there's our footer. Another option we could have, in fact, let's do this real quick. If I come into here and inspect this, you will see there's our wrapping div tag. But let's say I didn't want a wrapping div tag. Let's say I really did want to return just those two top level tags. No problem. React provides a very useful utility called react.fragment. For those of you who think what I just did was really cool in the editor in terms of being able to change both the starting and ending tag like that really easily, to do that, what I did was I came over to here in Visual Studio Code, and let me hit escape here. As I highlighted the div, I then did Control D, or if you're on Mac, it would be Command D, Control D, and then it highlighted both of those, and then I can say react.fragment. And then I can impress everybody with my editing skills. Now, it's actually a really useful feature. It's called multi-edit. A lot of editors support it, not just Visual Studio Code. I don't know what the hotkey is for things like Atom and stuff like that to be able to highlight it, but in Visual Studio Code on Windows and Linux it's Control-D, and on Mac it's Command-D. So if you go ahead and save that, you'll notice everything loads fine. Come back over to here. Let's inspect our DOM structure again. And I'm actually going to anchor this over to the side. And you'll see down here, our header and our footer are immediately under the div. So we can use React.fragment to serve as that top-level wrapper when we don't want that top-level wrapper to actually be rendered out to the DOM itself. Now, another thing we can do is we can attach things like classes, or if you're working with a label, an actual for attribute. But remember, we have to use special attribute names to be able to do that. So for example, I can come in here and say class name, and then I could give this some type of important class. We could say page header like that. All right, you'll notice it says class name, not class. If I come over here, my web browser, you'll see everything loads up just fine. However, let's say I forgot to put name, and I just had the word class. You'll notice you get invalid DOM property, did you mean class name? It'll also do the same thing for HTML4. So just something important to keep in mind when you're working with your JSX. Now, before we end this section, just for fun, let's actually come in here and let's go to the actual, well, let's first fix that and change that back to class name. Then let's come into our scripts or sources, and I actually want to show you the JavaScript file that's being produced here. So if we go under static.js, you'll see here's our bundle file. Now we don't want to look at the source map. Instead, what we want to do is I'd like to show you the actual code that's being transpiled from the JSX. Okay, so scroll down here. You can see here is our actual functional component. Var hello world, function hello world. So you notice the old school JavaScript syntax there. Webpack has definitely taken this thing back a few versions. See all of our create element calls, our fragment, create element. There's our header, our h1, there's our class name. This is what the code actually gets transpiled to. So all that JSX stuff is being literally transpiled to create element function calls, just as I mentioned before. So keep that in mind. JSX is not a string of HTML text. It is literally function calls. And so you have to treat those elements like functions in terms of how you structure your source code. As you can imagine, putting all of your components into one file is really not a best practice. Typically, JavaScript applications are going to have many files, hundreds, thousands of files. And so we need a way to kind of connect all these files together so that we don't have to put everything into one file. Back in ES 2015, lots of new things were added to JavaScript. One of those things that was added was something called ES 2015 modules. ES 2015 modules provide a nice import-export syntax that allow us to export things from one file and import them into another file. Now what's interesting is this, is that out of all the ES 2015 features, all of them have been implemented into modern JavaScript engines except for ES 2015 modules. And the question is, why? JavaScript by its very nature is very dynamic, which means you don't know what's going to happen until runtime. Older module systems, while not officially built into JavaScript, were built around this dynamic concept. Get what you need when you need it at runtime. Well, the problem with that approach is that you end up either having to load everything individually at runtime, or you end up having to make everything available at development time because you don't know what you're actually going to need until you start running the program. Well, the problem is you end up with a lot of inefficiencies. You end up with situations where you're having to download JavaScript files from the server constantly, or you end up with situations where you load up tons of JavaScript that you don't actually need to use and you'll never use. So, ES 2015 modules seek to deal with this problem through the use of a static module system. Well, the problem is JavaScript is not static at all. So trying to support ES 2015 modules as part of a JavaScript engine that is inherently dynamic is quite challenging to do. Therefore, what's happened is we've had bundling tools such as Webpack or Rollup, which have emerged. These tools are not part of the JavaScript engine, but they are part of the tooling for our project. They actually have the ability to read the ES 2015 module syntax and combine our files together, producing a single JavaScript file or a smaller set of JavaScript files, which can then be executed by the JavaScript environment. Now, to use tools like Webpack or Rollup require a fair amount of configuration. Now, configurations can be simple or super complex and hard, but usually when you get into a real application, you're pulling in so many different things, they actually grow to be quite complex. That's one of the reasons why we're using Create React App. Create React App provides us a fully configured Webpack configuration for doing our bundling, but it also provides us something called the Webpack Development Server. The Webpack Development Server rocks. The way this thing works is that when you're editing one of your hundreds or thousands of files, every time you save a file, it's watching for those changes and then reprocesses your code and reloads your web browser page so you can see the updated code almost immediately. Now, our Webpack configuration is configured to use the Babel transpiler for actually processing our JavaScript files. So Webpack will see when a file changes. It'll then go to load that file into the bundle, and then as part of loading it, performs the actual transpiling that is needed. Now, one thing you need to understand in order to work with the ES 2015 module system is that each JavaScript file is considered a module, and each module is a single JavaScript file. So we're really just talking about having a way to combine different JavaScript files together. So take a look here at some code we have doing our importing and exporting. There's two basic approaches that can be taken. One's known as a default import-export, and one is known as a named import-export. Now, I'll be honest with you, I love named imports and exports. However, most developers prefer default. So I'm going to show you both, and then you can choose whichever style you prefer, but using the style guide that your team uses, of course. So here's an example of a named export and import. So here I've got my hello world component, and I have export const hello world. This is going to be a named export of hello world. I can then import that inside of my other file, let's say app.js. I can import that, but I put curly braces around the word hello world, indicating this is a named import. I am specifically importing this one thing, hello world, from this other file. And then underneath of it, I can also alias hello world to another symbol if I'm going to have a name collision or something like that. So I could say instead of calling it hello world inside of app.js, we'll call it some other name. Now, one of the advantages of this approach is a big advantage to what ES 2015 modules do. The static nature of ES 2015 modules allow you to do something called tree shaking. So instead of pulling in the whole module, it only pulls in the things that you need from that module. In this case, I'm pulling in hello world and, of course, any dependencies that it has. The other type of import is a default export and import. In this case, we're basically just exporting one thing. And we're saying that this one thing is the default export, and then we can import it in our other file. You'll notice the big difference is that there's no curly braces around hello world in app.js. It just says import hello world. And if I want to use a different name, I just say import some other name. Because it's a default, we don't have to explicitly name what we're importing. It just gives us the default, and then we can assign whatever name we'd like to assign to it without having to formally alias it. Let's do a demonstration now of importing a component file. So now let's take a look at how to actually break our application up into multiple files. As you can imagine, putting all of our components into one file really isn't the way to go. In fact, most JavaScript applications are going to have lots and lots and lots of files. So coming back over to here, we're going to clean up our code a little bit. I'm I'm going to go ahead and get rid of our create element version of hello world, so we just have our regular hello world now. And down here we have our render function. Now what I want to do is I want to move the actual hello world component to its own actual file, and then we're going to import it. And we'll take a look at how to do a named import as well as how to do a default import. So what I like to do is under my source folders create a new folder, and I like to call it components. So there's components. I'm going to create a new file. I'm going to call it hello world.js. Now, for those of you with some React experience, you might be wondering why I'm not going to call it JSX. The reason why people originally called their files with a JSX extension was because they would have their JSX transpiler only be applied to those files. And this was really back in the day before transpilers were heavily used for all JavaScript applications. So there was actually a day in time when you wrote React code using ES5, the older version of JavaScript. And so the only reason you would actually need a transpiler would be to transpile JSX. So people would use a JSX extension, so the transpiling would only apply to those JSX files that actually use the JSX syntax. But since we're running all of our code through a transpiler now, not just the JSX, it doesn't really make a lot of sense to kind of segment some files to be JS files and some to be JSX. Instead, we just make all of the files to be JS files, and then each file goes through all the various plugins that are configured by the Babel transpiler. When it comes to naming the actual file, you'll notice I have capital H, capital W, hello world. Now, my actual preference is to do hello-world. I don't really like having mixed case characters in my file names. But the convention in the React community is to actually make hello world with uppercase H and uppercase W. So I'm going to do that here in this case for this particular video. So we're going to say hello world, and we're going to take our hello world component. I'm literally just going to copy all of this right here, and we're going to paste this directly into hello world. We do not need React DOM, so we just need to simply have React here. And the reason we need React is actually twofold. One, we are actually using React.fragment, so that's one reason we need it. But a second reason is that even if we weren't using React.fragment, even though you don't see React in any of the code, you have to realize that after the code gets transpiled, we are going to have a React symbol in the code. So we need to import React so we have access to that symbol so that for all of our transpiled React.createElement calls, everything works the way that we're expecting it to, in fact, work. Now, in order to make hello world available outside of this file, we have to export it. So we're first going to do the named export. We'll just simply put the word export in front of hello world, and we'll save. Now we're going to head over to index, and we're going to import hello world into this file. So we'll say import. Because it's a named import, we're going to include the curly braces, so import hello world from, and then we're going to do a relative file path. Components/hello world. There we go. Now, you'll notice that these imports up here are just simple names, whereas these are actual folder paths. The reason why these are simple names is because these are actually being loaded from the node modules folder, which you see here. So if you were to scroll all the way down and keep scrolling, you will see there's React and React DOM. So if you're importing something from the node modules folder that you've simply installed with npm, then you could just put the name. If you're importing one of your own files, then you actually need to put the ./components/hello world. You'll notice there is no extension listed here. It's just assumed to be JS. So we have import hello world from here, and then of course I can reference hello world, and everything works beautifully. Come back over to here, and you can see everything is loading up as you would expect. Now, let's say I already had a variable in here called hello world. And we'll just even make it assigned to null. Now you can see I have a problem. I have a naming conflict. To get around this using named imports, you could actually alias this and say we'll say hello world 2. And then down here I can reference hello world 2. And now everything works again. Now I'm getting a warning saying hello world is assigned a value that's never used, but that has nothing to do with the aliasing or what we're trying to render. That's just I have a variable that I've set up here that I'm not actually making use of. But you'll notice through the use of aliasing here, I'm actually able to rename the named import when I import it so that I don't have any naming conflicts. In addition to doing named imports, we can do default exports and imports. So I can come back over to hello world, and what I'm going to do is instead of saying export const hello world, I'm going to say export default hello world. And this will just be the default export that is exported from this file. So I'll come back over to here. I can get rid of the curly braces. And I can just say import. It'll take whatever that default is and just simply assign it now to hello world. Of course, I'll need to update my React DOM render. Head back over to Chrome, and the world's a happy place. Come back over to here. Let's say I wanted to rename this thing something else. So I could say something else. Come down here, paste that in here like this. So on the default, it doesn't matter what you call it in your local file because it's just literally taking the default and assigning it to it. And so now you can see we have hello world again. Now I will tell you, most of the React developer community prefers defaults, export importing of defaults. I actually prefer named imports, so I use named imports for all of my stuff that I work on. But the key is whatever the style guide says for your development team, that's what you want to make use of in terms of doing your exports and your imports. But just understand that there's such a thing as a named as well as a default. As you can imagine, we really don't want to hard code everything into our React component. In reality, we actually want to pull ultimately data from some type of data source, pull that into our UI application, and then pass that into our components. We're going to get to all that, but our first step is to kind of break away from simply hard coding everything and introducing some data, some logic, and actually dynamically build some aspects of our component. So to do that, we need to understand how we can place variables and expressions into our JSX. So take a look at our first code sample here. You can see where we've got header text as a variable being passed in as the third argument to create element, right? So that's pretty straightforward. Now let's take a look at how to do this with JSX. You'll notice in our h1 element, you'll see a set of curly braces surrounding header text. So instead of having to do the third argument to create element, we can simply put some curly braces in and then place our variable between them, and that will be evaluated as an expression inside of our JSX. Now you're not limited actually to just putting a variable. You can actually have any valid JavaScript expression in there. It'll evaluate it, and then the return value will be added to the component structure produced by the component. In addition to setting the content of an element, we also can set the attributes. So for example, take a look at our React create element h1 in the top example. We're basically having an object with a class name property, and we're assigning the name of our CSS class to it. We could do the same thing in JSX by simply just using the curly braces along with the rest of our attribute syntax as part of our h1 element. In fact, that class name equal to CSS class you see in the second example gets transpiled to the code you see in the first example. A lot of times we might have an interest in commenting our JSX code directly. To comment JSX code, you simply use the curly braces and then use a multi-line comment syntax from JavaScript. So we have open curly brace /* and then your comment */ close curly brace. Now, in addition to being able to pass in expressions, we also have the ability to run logic. One of the common logic structures is to do a loop. Well, the way that we do loops typically in JSX is through the array map function. We'll typically have an array of some type of data. We'll iterate over that data, producing an array of React components. In this case, we're going to produce an array of React list item components. So we have our array of items, iterate over that, produce a list item component for each individual item, and then take that array and add it to the output of our item list component. In addition to looping logic, it's often quite useful to have some type of control flow branching logic. For example, if this is true, then do this, otherwise do that. Well, because we're making all these function calls and we're doing all of these expressions, it's quite helpful to use the ternary operator to be able to introduce some of that branching logic. So you can see in this case, we're using the ternary operator to take a look at the age. Greater than or equal to 13, then say welcome. Otherwise, say you have to be 13 years of age or older to use this website. And then you can see the actual output here will be the span tag welcome. It's always good to keep in mind that when you're working with React and JSX, you are making function calls, as we've mentioned before. Take a look at what that ternary is transpiled into. It's actually transpiled into React.createElement calls. So even though the syntax for the JSX is very easy to read, do not think of it as a string of HTML. Instead, understand it for what it is, which is just an alternative syntax for making React.createElement function calls. Now sometimes a ternary operator may not be the best operator for you to use to implement your conditional logic. You might actually want to use an if statement. The challenge here is keeping in mind what we're working with. If you go with an if statement with actual if block, you'll need to introduce a return statement for each condition. So instead of returning the result of the ternary, inside of each block, so the if and then the else, you will then have your return statement returning back your React.createElement, or in this case, returning back the JSX. Another option is to use the double ampersand operator. You can actually also do this with the OR operator as well. And you can write a little bit of logic to basically choose whether or not to show something. Now, the interesting thing about this is that while a component can return a Boolean value, they are not directly outputted to the UI. So it's very convenient to introduce a little bit of conditional logic. So for example, in this case, if person.showAccountNum is true, then it will output the div. If it's false, it'll output the false, but because false isn't really outputted, nothing is displayed on the screen. So this is a really nice way to introduce some additional things with minimal amount of logic into the UI and being able to conditionally show or hide them. Let's do a demonstration now of embedding expressions into our JSX. So let's take a look at how to incorporate data and expressions into our JSX templates. First thing we're going to do is we're going to come over to our Hello World component. We're actually going to divide this up into two components. We'll come into here and we're going to create a new file, and we're going to call this one our tool footer.js, and we're going to rename Hello World to tool header.js. Now for tool header, we'll simply rename Hello World here, tool header, and I'm going to say export const, and I'm going to get rid of the default. There we go. I'm going to go ahead and ditch our React fragment and just keep the header there. And we'll pull, actually copy all that, and then we'll pull this out. And then we're going to come back over here to tool footer, paste all of this, and we're going to change this to be tool footer. And then we'll come into here and we'll get rid of header. We'll just simply have footer. There we go. And then the final thing we're going to do is we're going to come over to app here, and let's go ahead and delete the contents of app. So make all the app stuff go away. We'll say import star as React from React. And then what we're going to do is pull in tool header and tool footer, reference those here, and then we'll display app inside of index.js. So we'll say import tool header from /components /tool header, and we'll do import tool footer from /components /tool footer. Perfect. and we'll say export const app equal to, and simply come into here and we'll do our return div. In fact, actually, let's use our react.fragment. And then we're going to specify tool header, like that, and tool footer. There we go. Now we're going to take this app and we're going to actually import this over into index. So come into here. You can start to see how an application starts to grow really fast in terms of your files. You're going to literally have hundreds or thousands of component files. It's just the way React works. Lots and lots of components. And we actually use these components and compose them together like we are right now. So we have the header and the footer, and then we put both of those in app, and now we're going to reference app inside of index. We're composing these together to build our larger UI. So we'll go ahead and reference app there. If we pop over to our web page, you can see there's our hello world again. Everything's showing up good over there. So we'll come back over to our editor. And we're going to come to tool header first. And what we're going to do is we're going to begin this as a stepwise process. Ultimately, we'll pass this data in from the outside. But for right now, to demonstrate the use of an expression, we're actually going to incorporate the data here and then use the expression syntax to be able to represent it inside the JSX. So the first thing I'm going to do is actually switch this to a statement block. And I'll put my return statement here in front of header. And I'm going to get rid of my class name too. I don't really need that. Get rid of that. Now what I want to do is I'm going to create something called color tool. So I'll come into here and I'll say const, and then I'm going to say header text, and I'm going to say tool header. Alright, so there's color tool for my tool header, and I'm going to come down here and I'm going to replace this with my header text. There we go. So now I can save that, come back over to my web browser, and there you see I've got color tool. So I can simply define a variable, assign some text to it, and boom, I've got my actual text being displayed. Next thing I'm going to do is I'm going to come over to tool footer, make a couple of changes here. Instead of replacing this whole thing, I really just want this year to be dynamic. So I'll put my expression in here like this, and I'm going to say new date dot get full year, and that'll actually output the full year for me, and I can see that displayed here on my page. So that way when it goes to 2019, I don't have to remember to go back in and change that. So you can see in this case I'm actually newing up a date and calling get full year. You can put any valid JavaScript expression that you want into your JSX expressions, and then the return value of that is going to then be added to the content that gets displayed. So that's what a JSX expression is. We also have the ability to specify a comment. So for example, I could come into here and I could come over to my tool header and I could put a comment in here, and I could say, you know, to do pass header text in from outside the component. And we'll do that a little bit later on in this course. We'll actually pass that header text in from outside the component as opposed to hard coding it up here. But you can see I've got an actual comment now inside my JSX if you want to try to describe something that you want to either explain or to do or what have you to take care of later. So that's how you do comments. Now, let's take a look at some of the actual control flow looping structures. To do that, we're going to create ourselves a new component. It's going to be called item list. So we'll say new file, itemlist.js, and we'll come into here and say import star as React from React, export const item list equal to, there's our arrow function, and we're going to have ourselves a list of items. In this case, it's going to be a list of colors. Let's do red, green, and blue. And then what we want to do is we want to return back an unordered list of these colors. So we'll say return unordered list. There we go. And then I can simply take the items here and using our map function return back an array of list items. So I'll say items.map, item arrow, list item, and then we'll specify our item. Boom. There we go. So take a look. Now we have the ability to generate an array of list item elements, like you see here, and populate each one with a particular item in our list. Now I want to take item list here, and I want to import that over inside of app. So we'll come into here, we'll say import from ./components/item list, and then come into here and we'll say item list. Everything seems to transpile correctly. Head over to our web browser and you can see there's our actual list of items. So for fun, let's actually inspect our DOM structure again, make sure this looks the way we're expecting it to look. Come into here, here's our root, there's our header, there's our unordered list, that looks good, and there's our footer. But you'll see we have a problem. See the little error there? Even though everything's rendering out correctly, we're actually missing something called a key. Whenever you generate a dynamic list of something, a dynamic array of elements, you actually need to assign a key to those elements. In this particular case, we're going to use the actual item value as our key. Now, if you had, let's say, an array of objects, you would typically use the unique identifier. But we're going to use the item itself because we have a unique list of items. So I'll say key is equal to item. Now, we're not going to cover everything about keys now. We'll do that in a future course. Keys are really, really important, and if you don't use them properly, you can actually get some kind of weird behaviors that you might not expect. So we'll talk about those later, but for right now, to correctly get rid of the error, we'll specify a unique value, which is going to be the actual item itself. So now if you come back, you'll see the error is gone from the console. This is just another example of why it's so important to keep your console open so you can see when errors and stuff pop up on the screen. Now let's go ahead and take a look at a little bit of conditional logic. Let's say for whatever reason we didn't actually have any items in our list. We might want to display something that says, hey, you have no items. So what we could do is we could come into here and we could say items.length equal to 0 question mark. Now I like to put my question mark down on the next line, and if that's the case, then I want to return back a list item that says no list items. Otherwise, I want to return back my mapping operation. So now take a look at this. If it's 0, then return this. Otherwise, return back the array. Now, of course, if I switch back now, you'll see the actual list of colors. But what if I came into here and actually switched this to an empty array, commented that out? Now you'll see no list items. So using this ternary, we actually were able to implement a little bit of logic here. Now let's say we didn't want to use a ternary. Let's say we actually wanted to use a real if statement. I don't recommend that in this case, but let's say we did. Let's take a look at what that actual code would look like. To do an actual if statement in this case here, we would need to do something along these lines. If items.length is equal to 0, else, and then what we would do is we'd come into here and say return unordered list item, no list items, close that off, close off the unordered list. Then I could still do my mapping operation for when I did, but I'd have to take it like this. Return unordered list, boom. And of course, wrap this like that. Now using a standard if statement, that would accomplish the same thing. As you can see, it's a little bit longer, which isn't necessarily a reason not to use it, but I don't think it reads as easy as this one up here does, especially once you get used to the syntax. Keep in mind, don't make final decisions on which way you think is best because this is all still brand new for you if you're watching this video, right? Once you start coding with React every day, it's kind of funny how the things that seemed like the best way to do it on day 1 don't end up being the best way to do it on day 30. So keep that in mind. Be open-minded about using things like the ternary and this more functional approach as opposed to always creating these big statement blocks. You actually might find it's actually easier to read this here in the long run. Another important aspect of working with components is having the ability to pass data in. Just like in the last section where we didn't want to hard code everything, we also don't want to hard code our data either. So instead, we can use something called props to pass data in from the outside. Now this data can come from a parent component, or if it's the top level component, it can come from the surrounding lexical scope. Any data passed in via props is considered immutable in the component. This is extremely important. The component may never, ever, ever modify any data passed into it via props. We'll mention this again later on in this section. Now, if you take a look at our code here, you'll see we have a variable called user age set to 25, and we want to pass that into our age verification component. So user age is going to be the argument, that's the value in the curly braces, and it's going to be assigned to age, which is going to be the parameter. And then we will access age as the parameter off of the object that we'll call props. So if you take a look, we have return props.age greater than or equal to 13. The ability to pass in data from the outside is fundamental to doing React development. Now, we briefly saw this in the earlier section, but we want to highlight it now. When you set up your props on a component, those props are converted to an actual JavaScript object that is then passed into React.createElement. So take a look at it here. We have age equal to user age in the JSX. Then take a look at the object that's created. That's actually passed into createElement when the code is transpiled. You have an object literal with age, colon, and then set to the user age. Props are immutable. You literally cannot change them. In the case of the actual props object, React will freeze it and prevent you from changing it, which means you can't add properties, you can't remove properties, you can't modify the value of any properties. However, a lot of times properties on props will point to other objects. You cannot freeze those other objects because other things might need to modify them. However, your component is not allowed to modify them. Anything passed in via props from the perspective of your component is to be treated as immutable. So what happens if you were to mutate one of these props? The best way to think of it is like this. Let's say you're an employee working for your employer, and it comes time to get paid. It comes time for payday. Are you allowed to go into your employer's human resources system, load up your particular records, and modify your pay to what you want it to be? So tomorrow you'll get paid $1 million instead of being paid $2,000? No, of course not. Well, when props modify data that's been passed into them, it's doing that exact thing. It's going into some other variable's scope, modifying data that scope controls, and potentially causing a lot of other problems for components and other parts of the system that may be referencing that same data. Components can never, ever, ever, ever modify anything that comes in on props. Never. Never. If you think your particular situation is like the exception to the rule, you're wrong. They can never, ever be modified. You can never mutate props. You can never change props. You can never modify props inside of a component ever. Let's do a demonstration now of using props. Okay, so in our final demonstration here, let's go ahead and set it up so that our data is not hard-coded in the component. Rather, we actually pass it in from the outside. So for item list here, what we're going to do is we're going to come down here and we're actually going to comment out the if structure we created before and uncomment the ternary. We'll get rid of our items and remove that. And what we're going to do is actually come up here and specify props as our parameter. When you have no parameter or two or more parameters, you have to surround the parameter list, or lack thereof, with parentheses. But when you have a single parameter, you can actually just leave the parentheses off, as I'm doing here. Now, what I'm going to do is come into here and change this to be props.items and then props.items. And we're going to head over to app.js and we're going to pass in our colors as a separate thing. So we'll say const colors red, green, blue, and then we're going to take our colors here and we'll pass them in as our items. So we'll say items, colors. And actually, just for fun, let's throw in an extra color so we'll see something different. We'll say yellow as well. So we'll come over to our web browser and you'll see there's our four colors: red, green, blue, and yellow. And so now, instead of hard coding them inside of item list, we are now passing them in. We'll do the same thing here for tool header. We'll say header text, and then we're going to specify color tool. Oh, and actually for this one, we're not actually going to set up a variable. We're just going to hard code the text itself. And for that, you can just simply wrap it in quotes. And then we'll come over to tool header, and we can get rid of header text here. And we can say props. And then now we can say props.headerText. And we can get rid of our to do. There we go. So now if you come back over to your page, everything is loading up correctly. So these are called props, and they make your life a lot easier in terms of creating reusable components. You don't hard code all your data into the component. You simply pass it in as props, and then you can reuse the component over and over again. Now, we mentioned that props are frozen, and to kind of just demonstrate that here real quick, we'll say console.log, and we'll say object is frozen props. And if you come over to your web browser and open up your console window, you'll see it outputs true. So props are frozen. You can't modify anything on them. You can't add properties, remove, change any values. Also, if you're actually referencing properties that point to objects, you cannot mutate those objects. In fact, a good example of that is item list right here. If I were to come into here and say props.items equal to a new array, watch what happens. I get an error. Cannot assign to read-only items. And that's that whole process of being frozen. But let's say I did this instead. What if I said items.push and I pushed on orange as my color? You'll now see orange shows up and there's no error. This right here is a very evil piece of code. Never, ever do this. Never. Because you are permanently changing data that's managed outside of this component. In fact, what's interesting is if we actually come back over to app and we come into here and we actually copy and paste item list twice, take a look. We now have two oranges. Right? So the second time I call item list with the same original array, it now is displaying two oranges because I've added to it twice. This can cause all types of problems in your applications. Never, ever, ever, ever modify anything passed in on props. In the case of editing the actual props object itself directly, you'll get an error. And in the case of referencing objects off of it, you won't get an error, but it's still just as evil. So you can never, ever do this. This is very, very bad. If you're ever code reviewing people's code and you see something like this going on, you need to immediately kick their code back to them. This is really, really bad stuff. This is what I call the $1 million bug. These are the types of things that can sneak through testing, and then you get into production, and then you've got real problems in the UI because different components. You have to remember, the components you're building are not just for you to use. We always build all of our components with an eye towards reusability, which means other folks could be reusing our component 1 time or 100 times or 1,000 times. And so if we're mutating data that's being passed into it via props, we can cause all types of chaos. So in conclusion, we've learned that React components are user-face elements which encapsulate presentation logic and data. Data passes arguments into a component are called props. Data managed within a component is known as state. Components are composed together to build larger components. React is not limited to web browsers. It can be used for native mobile applications as well. To create React projects quickly, we use the Create React App tool. Create React App is distributed as a Node.js package, and it provides a complete development environment, which includes an actual development web server that includes bundling and transpiling provided by Webpack and Babel. We use the special syntax called JSX to make it easier to code the presentation logic of our React components. The presentation logic can be controlled using standard JavaScript control flow and looping structures, and then of course using APIs like the map function to be able to iterate over things. And then finally, props are an immutable data structure passed into the component for usage by the component, but the component is not allowed to modify or mutate it.